In this video, I'm going to show you how I built this walker mech behind me that actually walks along the ground. It even goes uphill. It's not a minecart contraption and it doesn't use train tracks. Think Boston Dynamics robot. Maybe more like... Normally, to make vehicles with Create, you can download Clockwork, which adds physics to the game, or you can use Create train tracks or minecart contraptions that run along rails or track that can be hidden under the ground. There are several flying machines you can make with the Create mod. The problem is that they tend to float at the same y-axis, or, because they don't know where the ground is, they'll smash through hills that get in their way. What we need to do is build a pair of legs that can attach to a flying machine, register where the ground is, and adjust the height of the body to match. Time for a terrible paint drawing. I want the legs to be able to move up and down by 2 blocks either way to allow the mech to incline and decline at a reasonable pace. For it to be able to do this, the leg that's moving, the front leg, needs to move up 2 blocks to clear that incline elevation. This means that when the front leg measures where the ground is, the ground can be anywhere between 0 and -4. If when the front leg has moved, it's extended 0 blocks to the ground, that means that the body needs to have risen by 2. If the front leg has moved down 2 blocks, that actually means the body hasn't moved at all. And if the front leg has gone down by 4, the mech's declining and the body needs to go down 2. With this in mind, I started designing legs. This process took almost 2 days. Most of the designs that I came up with were frankly terrible and just didn't work. Some completely missed the point of what we were trying to achieve. But I did learn that because we're in a super flat world and there's no air gaps down to bedrock, the Create sticky pistons don't push against the floor. And this was misleading me for a while because I thought this behavior was the sticky piston pushing its contraption until it met a non-contraption block. But it's just that it can't push bedrock. So I started designing the legs on a dirt platform, and you can see that the piston will push blocks if there's air gaps underneath, which is no good if there's a cave or just an air gap underneath where the machine is walking. It will start pushing the ground. So I had to really think about how I was going to get the legs to register where the ground was. I ended up using redstone contacts and started to finalize the design. I think I'm onto something here. This is pretty much just a Create piston flying machine. It's going to allow me to push the bottom part of the leg down until it meets the redstone contact on the ground, at which point the clutch will engage, the piston will unstick and retract, and then the lower piston, the one facing upwards, will be able to reach out and grab the upper piston, which is connected to the body, and pull the entire machine down to that level. At this point, I now just needed to figure out how to create that 2-block offset for the body. The smarty pants amongst you might be saying, but Woodchuck, if you're using redstone contacts, surely that's the same as using a minecart contraption or train track. And you would be right. But I am not that smart, and it's going to take me another 5-10 minutes to figure that out. But there is a solution. Just hang in there. This is now 2 flying machines. So there's actually 3 parts here. There's the yellow section, the green section, and the blue section. And what this allows me to do is push the blue section away from the green section to measure how far away the ground is. And then the yellow section, we can push that away, which the yellow section is the body. We can push that away from the green section to create the 2-block offset. This piston will allow us to reach down and grab the entire leg and pull it up to the body to lift it to move. and then once it's moved, this piston at the bottom can extend and measure how far away the ground is, and then this piston here will extend back up, grab the body, and pull it all down. I've made a few tweaks to the leg from this design. It's pretty much exactly the same. I've just added some redstone contacts on the back to allow the bottom piston and the very top piston to find this middle section. I've also changed all of the wool to wood because it was giving me a headache, as I had coloured wool for the different parts of the body and coloured wool on the frequencies of the redstone links. At this point, I think I have a working leg design. So I build a redstone contact track, I schematic the legs onto a body, and now we're ready to start sequencing the movement of the legs. This is the part where I start to lose the plot. Here is the sequence as I have it so far in my head. Please ignore the cows. The leg begins detached from the body. This is important later at the end of the sequence. The top piston grabs the leg and pulls it up to meet the body. The body is then pushed up by the leg to create that 2-block offset. The body rotates, moving the leg forwards. The lower part of the leg then extends to meet the ground and hits the redstone contact. That lower leg then retracts, pulling the body down to the correct height. The leg then detaches from the body. This is important when we switch to the other leg and the process repeats, because as the body is moving up and down, if the back leg is still attached, it's going to turn into a whole mess. Here I've translated that sequence into redstone. You can see each part of the sequence has its own triggerable redstone link at the bottom. A note on the frequency links, I'm using the part that the link is attached to in the upper slot when it's the top piston, and in the lower slot when it's the bottom piston, and the other slot is occupied by a piece of coloured wool, which denotes whether it's the upper part of the leg or the lower part. On the left leg it's red and yellow, and on the right leg it's blue and green. I created a schematic of the blue and green parts, flipped it, and printed it on the other side, and this is the sequence that brings it all together. Each of the sections that we've programmed can be fired, then there's a time delay that allows it to complete its action, and then the next one fires. At the end of the circuit, it just switches over to the other leg, and that begins the process again. At the beginning of the circuit and at the end, there are 2 skips. The skips are just there to avoid times when the pistons are already in the position that they need to be in. We take a signal from the redstone contact. If it's already on, that means that this comparator will unlock and we can skip a few of the steps that we don't need to be doing. This occurs when we go up an incline, as the foot already makes contact with the ground immediately, and it occurs when we go down a decline because the body has been pulled down so that the top section is actually already connected to the body. I hope this is all still making sense and you are as excited as I am to see this thing in motion, assuming that it actually works. I'm a little nervous, just a little. Let's give it a go. First step, those 2 stick. This piston should extend. Okay, we failed at the first hurdle, that's cool. And so began a series of painful failures. Every time I thought I had the machine working just right, something else would go wrong. Ooh. Okay. It got to the point where it was mostly my mistakes causing the errors. What's gone wrong here? I was tired. I forgot to unglue things. I'd start the sequence in the wrong place, and I was really starting to lose faith. Oh, it is. Oh, it didn't work. Interesting. I wonder why that didn't. Oh. I've just noticed an interesting behavior that I think is really going to change how this machine works. Currently, we're still working on this idea of using redstone contacts and creating these tracks, which kind of defeats the whole purpose of what I'm trying to do here. I set out to make a machine that could walk without using clockwork, but without using create train tracks at the same time, or a minecart contraption. And what is this if not a track of a different kind that's also even harder to set up and place and requires a lot of resources and time to set it up. It's actually an interesting behavior with the sticky pistons that I hadn't noticed before, but I think I've been seeing this entire time as the contraption has been messing up, that we can take advantage of. Let me show you with an example. I'm not going to pretend like I absolutely understand what's happening here, but the sticky, when it's stuck, is treating this as the entire contraption. And so the piston thinks it can push everything. But when the sticky is unstuck, for some reason, it treats this as an immovable block, as if it's part of a separate contraption. I don't really know why it's happening, but it means that we can come over here and we can just replace the feet of our guy here with stickies that aren't powered. They never have to be powered. We don't have to toggle them at any point. Wow, I'm really struggling to place these. This behavior is going to be exactly the same as this part of the leg extending and stopping when it hits a redstone contact. It's just going to stop when it hits the ground. This is huge. This changes the whole thing. It puts us right back where we're supposed to be, which is creating a walker that actually walks on the ground. It doesn't rely on any of this external stuff. We can get rid of all of this. I think I just got a little lost in the design process. I lost sight of what I was trying to do. I think this is way better. I'm gonna have a little fiddle around with the circuitry and bring you back when I think it will actually walk. I know I've been saying that for the past 10 minutes. That was a full leg rotation using these new sticky piston feet. This is working. This walks wherever you want now. You don't have to build roads for it. You can just set it up and it will go. Oh, that's cool. That's very cool. Okay, I'm gonna connect it up and we're gonna give it a little walk just to see how it goes. It is very slow, but I don't care at this point. This is cool. It works. Right, okay, I am just going to start slapping some dirt down in front of this thing and seeing what happens. So let's see what happens if it can go up one block. And then back down. This guy over here, he's about to step. He's about to step. And he's only got one block to go down. So the whole body should move up one, because there's only one gap here. So it's been up two, it's getting pulled down one. It's climbed. The machine is climbing. Okay, we have a walking machine. It can go uphill. I'm pretty sure it can go downhill. I don't see why not. Maybe it just needs a little bit of timing adjustment. But we have a walker. We have a walker. That is exciting. And I'm going to make a schematic of this, put it in a creative world that has generated terrain, and see how it does. I'm sat on the back of a walking robot. It's walking across all of this terrain and it's self-correcting. It's probably about to crash into the hill in front of me, and I know it's not going anywhere fast, but you could put an entire base on the back of this thing and have a base that just walks around. I'm going to make a part 2 in the next couple of weeks where we decorate the mech. It's pretty ugly at the moment, I know. And I want to try and put that brain that's in the background on top of the body. I really want to try and speed it up. I know it's slow. And maybe, just maybe, we'll put a base on the back. Thank you so much for watching. Please like, comment, and subscribe. Especially comment. I really want to know your ideas for inventions and what you would do with this mech. I hope you enjoyed the video, and I'll see you next time.